So we are going to start first chapter of class 12, that is relations and functions. So relations already we have learned in class 11. क्लास 11 में रिलेशन ऑलरेडी हम लोग सीख चुके हैं. तो वहां पे हम लोग क्या सीखा था? रिलेशन इज ए सबसेट ऑफ कार्टेशियन प्रोडक्ट बिटवीन टू सेट्स, राइट? So Cartesian product between A and B, subset of Cartesian product of A and B is called the relations. And relations में हम लोग और एक चीज देखा था, it is a collection of ordered paired. So ordered paired का जो फर्स्ट एलिमेंट होगा उसका कलेक्शन को हम लोग बोला था डोमेन, और कलेक्शन ऑफ सेकेंड एलिमेंट ऑफ ऑर्डर पेयर इज कॉल्ड रेंज, and second set is called codomain. These three terms you got in class 11 chapter 2, that is chapter 2.2. At that place relations we got. Now in class 12 we'll get types of relations. The definitions of relation you have to keep in your mind, domain of the relation you have to keep in your mind, then range of relation you have to keep in your mind, okay, and what is codomain, that also you have to keep in your mind. And we'll learn here types of relations. So to show it, I'm showing video related to relation and function. Just check it. Okay.
In this module, you will learn about different types of relations and their properties. Let's take a quick look at relations that you learnt in your previous class. A relation R from a non-empty set A to another non-empty set B is a subset of the Cartesian product of A and B. The subset R is derived by describing a relationship between the first element and the second element of the ordered pairs in A cross B. Let us see an example to make our concept stronger. Here, we have to find a relation R from A to B such that for any A in A and B in B, A is a factor of B and also A is less than B. That is, in the given sets A and B, we have to find the set of ordered pairs A, B such that A is a factor of B and A is less than B. Let 2 and 4 be any arbitrary elements of sets A and B, respectively. Now, 2 is a factor of 4 and also 2 is less than 4. So, 2, 4 is one such ordered pair that satisfies relation R. Likewise, other such ordered pairs can be obtained. Thus, the set of all the ordered pairs so formed is the relation R, which is as shown. The set of all the first elements of the ordered pairs in a relation R from a set A to a set B is called the domain of the relation R, and the set of all the second elements of the ordered pairs is called the range of R. If the ordered pair A, B belongs to set R, then we say that A is related to B, which is denoted by ARB. You also learned that if the number of elements in set A is P, and the number of elements in set B is Q, then the total number of elements in the Cartesian product of A and B is PQ, and the total number of possible relations from set A to set B is 2 raised to the power of pq. Let us now learn about the different types of relations. Consider set A with elements 1, 2, 3 and 4. The Cartesian product of A with itself consists of 16 ordered pairs, as shown here. Let us define a relation R on A, defined as the set of all ordered pairs x, y, such that x plus y is equal to 15. Recall that any relation R in A is a subset of A cross A. In this case, no ordered pair satisfies the condition that the sum of their elements is 15. Hence, relation R has no ordered pairs in it. These types of relations are known as empty relations. Mathematically, a relation R in a set A is called an empty relation if no element of A is related to any element of A. That is, R is an empty set and is a subset of A cross A. Proceeding further, let us define a relation R in A as the set of ordered pairs x, y, such that x plus y is less than or equal to 8. Choose any arbitrary ordered pair from A cross A. Observe that the sum of its elements is less than or equal to 8. Here, all the ordered pairs satisfy the condition that the sum of their elements is less than or equal to 8. Hence, we get a relation R that has all the ordered pairs present in A cross A. This type of a relation is known as the universal relation or total relation. Mathematically, a relation R in a set A is called a universal relation or total relation if every element of A is related to every element of A. That is, R is equal to A cross A. An empty relation and the universal relation are sometimes called trivial relations. There are 4 different types of relations. Let's first see when a relation is said to be reflexive.
So here we'll learn main types of relation: reflexive relation, symmetric relation, transitive relation, and equivalent relations. Okay, Prince, understood?
Yes, sir.
Okay, so very carefully you will observe what is reflexive relation, okay, what is symmetric relation, and what is transitive relation. So simultaneously I'll explain also.
T be the set of all triangles in a plane. Define the relation R in T by the set of ordered pairs T1, T2 such that T1 is similar to T2. If an ordered pair T1, T1 is in set R, then it implies that T1 is similar to itself, which is true, since every triangle is similar to itself. And this holds true for all the triangles in set T. Hence, we can say that every element of set R is related to itself. Such types of relations are called reflexive relations. Mathematically, a relation R in T is said to be reflexive if every element of set R is related to itself. That is, the ordered pair x, x belongs to R for every x in T.
Okay, so understood this reflexive relation? So reflexive relation, okay, just I'm explaining. Just check it. So, first type of relation is the reflexive relation. Reflexive relation. Now try to understand reflexive relation. Okay, let R be a relation defined on set A. Okay, if for all A belongs to A, for all, here I have written for all symbol, AA ordered paired belongs to R, then we can say that then R is reflexive. Understood?
Yes,
As
sir.
for example, one example I am giving. Suppose A equals to 1, 2, 3 and consider a relation 1, 1, 2, 2, 1, 3. Since this is a subset of A cross A, so R is a relation. Okay, define on A. So can you say R is reflexive? It is relation. But can you say it is reflexive?
No, sir.
Because A contain 1, 2 and 3. 1, 1 is present, 2, 2 is present. That means 1 is related to 1, 2 is related to 2. But 3 is not related to 3. So we can say that it is not reflexive. Understood?
Yes, sir.
Okay. So I'll wrap this. Now we'll understand symmetric. What is the meaning of symmetric? Whatever definition you want, you can give. But here, one thing you will keep in your mind. For all symbol you will use, for all small a belongs to capital A. If A belongs to R, then we can say that R is reflexive. Otherwise, we can't say it is reflexive. Okay. Now, just check when we can
Next,
see
let's see when a relation is said to be symmetric. Again, consider the same relation R in T defined by T1, T2 such that T1 is similar to T2. Let T1, T2 be an ordered pair in set R. Then it will imply that T1 is similar to T2. So we can also say T2 is also similar to T1. This implies the ordered pair T2, T1 is also in R. Such relations are called symmetric relations. Mathematically, a relation R in a set T is said to be symmetric if ordered pair x, y belongs to R, implies that ordered pair y, x is also in R for all x and y in T.
So, what you understood the meaning of this? Again, I'm explaining the meaning of this. So, second type of relation is symmetric. Symmetric relation. Okay. So, here we'll write let R be a relation defined on set A if AB belongs to R. implies BA also belongs to R. That means if AB belongs to R, then BA should be also there. Here I am not saying all elements of A. If AB belongs to R, then BA should be belongs to R. Then we can say that then R is symmetric. Right.
Yes, sir.
So here you will check in a relation, if AB ordered pair is there, then BA should be also there. Then we can say that it is symmetric. So I hope you understood the meaning of symmetric. Now we'll understand transitive. So these three kind of relations, main relations we have to learn in class 12. Okay. Now just
Let us take one contradictory example. Relation R in the set 1, 2, 3 is not symmetric. This is because the ordered pair 1, 3 belongs to R, but 3, 1 doesn't. Note that it is wrong to say that it is sometimes symmetric or is symmetric as far as 1 and 2 are concerned, since being symmetric is a property of the whole relation. Let us now move on to transitive relations. A relation R in T is said to be transitive. If x, y and y, z belongs to R, implies that ordered pair x, z also belongs to set R. Let's check the
now try to understand the meaning of this. Right. So third type of relations will be transitive relation. Let R be a relation on set A. If, here also if AB, BC belongs to A, then AC also should be belongs to A. Then R is called transitive relation. Actually, here one very interesting fact I want to share with you. Just giving one example, I'm showing one relation. Suppose A equals to 1, 2, 3. And I am taking one relation R equals to 2, 3 and 1, 1. So this is relation because it is a subset of A cross A. Now if I'll ask, is it a reflexive? What will be your answer? Is it a reflexive relation?
No, sir.
No. Because 1, 1 present but 2, 2 not there, 3, 3 not there. Is it a symmetric relation?
No, sir.
Is it a transitive relation?
No, sir.
Yes, sir. Yes, it is transitive.
Sir, how?
Transitive relation. In definition, what I said, if ABBC types of ordered pair present, sorry, here it should be R, not A. By mistake I have written. And AC also belongs to R. Right? It is not A. Okay. So here I said in definition, if ABBC belongs to R, then AC should be belongs to R. And if ABBC type of relation is not present, then contradiction will not come. AC is present or not. Here it is happening 2, 3 and 1, 1. Here we are not getting any ABBC type of ordered pair. That means first ordered pair, second element of first ordered pair, and first element of second ordered pair. Same, we are not getting this kind of ordered pair here. If we are not getting, so contradiction also will not come. Yes or no?
Yes,
If
sir.
contradiction will not come, then we'll tell it is transitive relation. You will remember this. Understood
Okay.
this point?
Yes, sir.
Yeah. So now few more concept we'll see, and then we can start.
Transitivity of the relation R in T, which is defined by the set of ordered pairs T1, T2, such that T1 is similar to T2. Consider the ordered pairs T1, T2 and T2, T3 in set R. By definition, T1 is similar to T2 and T2 is similar to T3. Now, T2 is similar to both T1 and T3, so this implies that T1 is similar to T3. This in turn implies that the ordered pair T1, T3 belong to set R. Hence, ordered pairs T1, T2 and T2, T3 belong to set R implies that T1, T3 is also in R. This shows that the relation R in T is transitive. Now, let's come back to relation R in set T. We observed that the relation R in T is reflexive, symmetric, and transitive. Such a relation R in T is called an equivalence relation. Mathematically, a relation is said to be equivalence relation if it is reflexive, symmetric, and transitive. In this module,
So here we have learned, okay, what is equivalence relations. Okay, so a function, for functions we'll make different videos. So relation, that concept we got, right? So if a relation is a reflexive, symmetric, and transitive, then we can say that it is an equivalence relation. So understood?
Yes, sir.
Okay, fine. Now we'll start exercise. This much is required. Basically reflexive, symmetric, transitive, and equivalence relation. Equivalence relation, if you want to prove, then you have to prove it is reflexive or not, it is symmetric or not, it is transitive or not. And reflexive, for all element reflection should be there. If A contain 3 elements, then 3 elements, all reflection should be there. Suppose 2 elements reflection is there and 1 is not there, then you can't say that is reflexive. Symmetric, if AB belongs to R, then BA should be belongs to R. Here for all not required. Okay. And third one, if ABBC belongs to R, then AC belongs to R. If this type of ordered pair is not present, then you can say it is transitive. You can't say it is not transitive. You will say it is transitive. So now we'll start exercise. So this is our NCERT portions. Okay. So we'll start. First question. Answer 1. Determine whether each of the following relation is reflexive, symmetric or transitive or not. Achha, relation are defined in a set A equals to 1, 2, 3, 3 dots, 13 and 14. And R equals to xy such that 3x minus y equals to 0. That means y equals to 3x. So write in roster form, then it will be easy. Y equals to 3x. So value of x if you take 1, right? Then value of y will be 3. If value of x you will take 2, then y will be 6. If x is 3, then y will be how much?
9.
9. If x is 4, then y will be
12.
12. If x is 5, then y will be 15, but 15 is not present in set A, so this
We
much.
will not write it.
Now, clearly check reflexive or not.
So it is not reflexive.
If not reflexive, then one example is sufficient. 1 each belongs to A, but 1 does not belongs to R. Therefore, R is not
Reflexive.
reflexive. If you are proving reflexive or not, if it is not reflexive, one example is sufficient. Then symmetric. Check it is symmetric or not. Clearly 1, 3 belongs to R,
But 3 1 does not belong to her.
3, 1 does not belongs to R. So we can say that R is not symmetric. Now transitive. Transitive. So AB, BC type of ordered pair present or not, just check it. 1, 3 and 3, 9. Yes, we are getting. So 1, 3, 3, 9 belongs to R, but 1, 9 does not belongs to R. Therefore, R is
Not transitive.
not transitive. Not transitive. Understood?
Yes, sir.
Achha. Question number 2 also similar type. I'm not doing. Third one I'm doing. Now, answer 1.
Third.
So I'll make 2 videos. from a relation. So today, whatever questions we can discuss, we'll discuss in next video. Remaining questions we'll discuss. So third questions, relation are defined on age. So age, what is given? 1, 2, 3, 4, 5, 6, and R equals to X, Y, such that Y is divisible by X. Okay,
Yes, sir.
so we have to take ordered pairs such that Y is divisible by X. So in roster form, you want to express, I think it will be lengthy or what? Yeah, not lengthy. If you will take X is 1, then we can take 1, 1. We can take 1, 2 also. Y should be divisible by X. Then we can take 1, 3 also. Then we can take 1, 4 also. Then we can take 1, 5 also. Then we can take 1, 6 also.
Yes, sir.
Achha. 2 we can take, 2, 1 we can't take. Then 2, 3 we can't take.
2, 4.
2, 4 we have to take. And 2, 6 we can take. Y should be divisible by X. Then 3 we can take on, and we can take 3, 6. Then 4 we can take only, right? And
Yes.
5 we can take, and we can take 6, 6. Okay. Now tell, is it reflexive?
Yes, sir. It is reflexive.
So how will you write? Now if it is reflexive, don't give example. Here you will write, for all small a belongs to capital A belongs to R. Therefore, R is reflexive, right? So R is reflexive. Understood?
Yes, sir.
Acha, now symmetric. Symmetric, check.
No, sir. It won't be symmetric.
Yeah. Now if it is not symmetric, one example sufficient. Right? Anyone you can take. 1, 4 belongs to R, but 4, 1 does not belongs to R. Therefore, R is
Not symmetric.
not symmetric, right?
Yes, sir.
Now, check transitive or not. Transitive. Is it a transitive? Acha, here we are getting okay. So 2666. Any contradiction we are getting?
No, sir. It
One
is transitive.
1555. No, we are not getting any contradiction here. That
Yes,
means
sir.
ABBC type of ordered pair so we are getting. But A and C if you take, then we are getting same answer. Okay, just check answer. Since AB BC belongs to R, implies AC also belongs to R. Therefore, R is
Transitive.
transitive. Check answer.
Yes, sir. It's written. It's reflexive and transitive.
Transitive. Okay. Now one interacts in interesting questions I'm showing to you. Okay. So I'm showing you question number 5. Question number 5D. So answer 1, 5th D. Relation are in the set A of human being in a town at a particular time given by. That means A equals to set of human being in a town. In a town, right? And R is given X, Y such that X is wife of Y. Right? So that means you are taking ordered pairs so that X will be the wife of Y. You can collect this type of many families. You will get husband wife. You can collect that will be the elements of that relation. Is it reflexive or not? So if same element, suppose X should not be wife of X, is it possible?
Mm,
If you are checking it is reflexive or not, X belongs to, or here take A belongs to, because we are taking A. Any symbol you can give, it is no boundaries. Suppose A belongs to A. Okay. So A should not be, A is not wife of A. Right? It means AA does not belongs to R.
yes, sir.
So R is
Reflexive.
R is not reflexive. Right? Sure. Now symmetric. Now tell me, if A is wife of B, So A is female, B is male. Then B is not possible to wife of A. If AB belongs to R, it means A is wife of B. B is not wife of A. Understood?
Yes, sir.
So we can say that BA does not belongs to R. Therefore, R is not symmetric. R is
Not symmetric.
not symmetric. Now think about transitive.
सर ट्रांजिटिव भी नहीं होगा.
ये देखो सीधा बोल दिया ना, ट्रांजिटिव नहीं होगा. क्या उसमें ऐसा ऑर्डर्ड पेयर्ड होगा जो ए बी बी सी बिलोंग्स टू आर हो?
नहीं सर.
अगर ए बी होता है तो ए इज वाइफ ऑफ बी. अब बी
Yes,
तो
sir.
किसी का वाइफ नहीं हो सकता.
नो सर.
सिंस ए बी बी सी type of ordered pairs are not present in R. तो हमें चेक भी नहीं करना है. अगर R में ए बी बी सी टाइप ऑफ ऑर्डर पेयर ही नहीं है तो फिर क्यों चेक करें? तो ऑटोमेटिक ए क्या होगा? R इज
नॉट ट्रांजिटिव.
ट्रांजिटिव.
सर यार इज ट्रांजिटिव. ट्रांजिटिव.
ये गलती मत करना.
यस सर.
राइट? कॉन्ट्रडिक्शन नहीं आ रहा है तो ये ऑटोमेटिक ट्रांजिटिव होगा. अगर हमें ऐसा मिलता जो ए बी है बी सी है लेकिन ए सी नहीं है, राइट, इफ ए बी प्रेजेंट बी सी प्रेजेंट बट ए सी नॉट प्रेजेंट, तो फिर बोलते जो या इट इज नॉट ट्रांजिटिव. सो देखो रिफ्लेक्सिव, सिमेट्रिक, ट्रांजिटिव, इस तरीके से हम लोग चेक करते हैं. तो देखो एग्जाम में दो टाइप का क्वेश्चन आता है. या तो बोलेगा चेक करो या बोलेगा प्रूव करो. अगर प्रूव करने बोला जो इक्विवेलेंस रिलेशन प्रूव करो, इसका मतलब तो समझ ही चुके जो पक्का क्या हुआ. प्रूव करने बोला है तो वो रिफ्लेक्सिव है, सिमेट्रिक है, ट्रांजिटिव. पर चेक वाला क्वेश्चंस ठीक है बहुत केयरफुली करना होता है. चेक में क्या हुआ, तुम्हारा थिंकिंग स्किल का जरूरत होगा. You have to, if it is not reflexive, you have to give one example. If it is reflexive, then in general you have to give. Giving one example, you can't say it is reflexive. Or giving one example, you can't say it is symmetric. ऐसा भी तो हो सकता है जो एक के लिए क्या हुआ ट्रू है, दूसरा ऑर्डर पेयर के लिए ट्रू नहीं भी हो सकता है. अंडरस्टूड?
यस सर अंडरस्टूड.
तो ये तो था हम लोग का जस्ट इंट्रोडक्शन पार्ट, जो हम लोग यहाँ पे सीखा. रिफ्लेक्सिव क्या होता है, सिमेट्रिक क्या होता है, ट्रांजिटिव क्या होता है, उसको चेक करना सीखा. आप देखो इक्विवेलेंस रिलेशन टाइप ऑफ क्वेश्चंस को प्रूव करना सिखाएंगे. और यहाँ पे टू क्वेश्चंस, क्वेश्चन नंबर 2 एंड क्वेश्चन नंबर 4, वेरी गुड क्वेश्चन, वेरी इंपॉर्टेंट क्वेश्चंस, मेनी टाइम केम इन बोर्ड एग्जामिनेशन. तो इस दोनों क्वेश्चंस को करेंगे, प्लस इक्विवेलेंस रिलेशन कैसे प्रूव करते हैं, दैट टाइप ऑफ क्वेश्चंस वी डू इन नेक्स्ट वीडियो. सो I'll end video here. Okay.